Alright, this is video 8.2. We're looking at solving linear equations of a specific form. That's a over x is equal to b. So a slight variation on some of the ones that we did in video 8.1. Basically, we're going to have to add one additional step. The reason why we need to add one additional step really comes from we just need to be clear what we mean when we're isolating a variable. Right? Algebra, we're trying to isolate the variable. That isolated variable needs to be in the numerator, not in the denominator. Okay? So in other words, you're not asked to solve for something that's 1 over x. You want to instead solve for it when it's x is equal to. Okay? So this is not what you want to do, this is what you want to do. So when you have a linear equation that's given to you that has the variable in the denominator, we're going to need to do something to make sure that it doesn't stay there. Okay? So we can simply add one extra step, and we're going to do a couple of those, and then I'll show you a little trick that you might be able to use from time to time as well. But we'll show you the proper way first. Okay, so an example here, -5 is equal to 1 over a. Okay, so in the past video we said, well, what's happening to the variable, and then we're going to undo it by doing the other operation. Well, the thing is, the variable here is in the denominator, so before we do anything, we want to get that variable to the numerator. Okay, so the way that we're going to do that is recognize right now 1 is being divided by a. If we multiplied by a, the right side by a, what we would do, okay, is get rid of that variable in the denominator. And again, remembering this equal sign there means if we multiply by one side by a, we got to multiply the other side by a as well. Okay, so we're multiplying by a. So now we have -5a on the left side, and we were just left with the 1 over on the other side. Well, now this looks exactly the same as the type that we already know how to do, and it's going to be easy to solve that. We're just going to recognize now that a is being multiplied by -5. To undo that, we're going to divide by -5. Got to do that to the other side as well, and your answer is going to be a is equal to 1 over -5. Okay? So we had to switch things around a little bit, take one extra step to do it, but now we've got a in the numerator. We didn't solve for 1 over a. We've got just a on its own, which is what we wanted in the first place. Okay, do another example here. 14 is equal to 7 over x. Okay, so same thing, x is in the denominator. It's no good down there, we got to get it to the numerator. So we're going to get rid of it on the one side, get rid of it in the denominator by multiplying by x. That cancels off. What we do to one side, we've got to make sure we do to the other side. So multiply by the other side by x, so we're left with 14 times x, and that's going to be equal to 7. Now we've got what we had before. We recognize that x is being multiplied by 14, so we divide it by 14 to get rid of that. Cross that out. We had to do that to the other side as well. We have x is equal to 7 over 14, which simplifies nicely to 1/2. Okay? That's the long way of doing it. I want to show you a little trick, and some of you will get this, some of you won't. Don't worry about it if you don't. The way that I've showed you will always work, and it's the most complete way because it shows you the understanding as well. But I'm going to show you just a little trick that, if you get it, might save you a little bit of time. And I know that you guys are all into that. So I'll leave the answers up there so you'll see that we get them the same way, or end up with the same answers. But I'll just quickly show you this little trick. Okay, it is true that you are able to mathematically, and based on the examples that we just finished doing, okay, you can interchange the numerator on one side with the denominator on the other side. Okay? So this -5 is in the numerator on the left side, the a is in the denominator on the right side, we are allowed to swap them out. Okay, so those can simply switch places. So now I would have a on one side and negative 5 on the bottom. Oh, look at that. That's exactly what we ended up with before. Okay, nice little trick. You just swap the numerator on one side and the denominator on the other side. Same thing down here. 14 is equal to 7 over x. Well, I'm going to see that and swap out the numerator on one side, the denominator on the other. So I've got now x is equal to 7 over 14, which simplifies to 1/2, which is what I had before. Okay, so you might be able to do that a little bit faster if you recognize that. But like I said, the other way will always work as well. So don't get confused by that if it didn't work for you. Okay, one other example here that's a little bit of a story problem. Okay, we're given the formula for speed. S is equal to d over t. So S is speed, d is distance, t is time. We've got an example here, a musher and her dog team averaged 23.5 kilometers per hour during a dog sled race. How long will it take to sled 50 kilometers? So what's the question actually asking? How long? That's a time thing. Okay, so we're going to try to find time. Do we have a formula that's going to work with that? Sure we do. We're given one in the question. So S is equal to d over t. We're going to plug in what we know. Okay, what's the speed? Well, speed's given to us right there, 23.5 kilometers per hour. That's going to be equal to the distance. We're trying to find out how long it takes to go 50 kilometers, and t is our variable that we don't yet know. Okay, so now we got an equation, a linear equation that's set up the same way as what we just did. Okay, we can do it the long way that we did before, or we can do our trick of swapping out the numerator in one and the denominator for the other. I'll quickly do the first one just to reinforce that one. Okay, multiply both sides by t. Okay, so that leaves us with 23.5 times t is going to be equal to 50. Okay, now I see that 23.5 is multiplied by t, so I am going to divide both sides by 23.5. Okay, 23.5's cancel over there. T is going to be equal to just a little bit more than 2. You could plug that in on your calculator if you need to. It's probably going to be about 2.1 hours. Okay, so that is a story example, or a application example, I guess, of how you would use this type of algebra. Okay, hope that is helpful.